How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have two 651 apron cylinder pistons to be remade. So what the apron cylinder does is it closes the apron door on the front of the scraper. While the machine is taking the cut, the apron door is open. It fills the bowl up with dirt. The apron door is then closed so they can carry it on to another part of the job site. When they get to where they want to go, they lift the apron door, push the ejector door out, and it spills the material out the front of the bowl. The apron doors do cop a hell of a flogging because they are trying to pick up big rocks and you can't really see what's happening in front of the bowl. So if there is a big rock there, you're trying to close the apron door on it and it shock loads the cylinder. There are two main failures with apron cylinders, and they either rip the rod in half or they start to stretch out the rod. What actually happened to these pistons is known as metal fatigue. Over time, material starts to move and stretch. What started this failure would have been the tapers in the piston becoming loose because the rod has begun to stretch. Once the threaded end of the rod starts to stretch, that allows the piston to move down that taper just a little bit, and then everything starts to move around. So the piston starts to kick sideways as it's cycling. Then there's interference between the taper and the piston. It starts to create metal fragments. The metal falls down in beside the piston and the barrel, and then you have the three main components to a cylinder that are then destroyed. So we do have the two barrels here that need to be rebarreled. The insides of them are totally destroyed, and we do have the rods here in order to be reclaimed as well. So the other way this failure can happen is if the nut on the bottom of the rod that holds the piston on is not done up to the correct torque. If it's over torqued, you can pre-tension everything and things will start to fail early, or if it's not done up tight enough, this failure can occur. So this piston was damaged far worse than the other one. They actually had to bash it off with a hammer off the end of the rod because it had created so much metal they just couldn't remove it. And this piston here, it is probably borderline repairable. You could go through the effort to clean it up, machine down the OD, use silicon bronze or some other sort of filler material, machine it back to size, and it would probably run again. But the customer doesn't want to do that because we are building two brand new barrels and two brand new rods. They don't want to put a part that's already been through the process of being repaired back into a brand new cylinder. So let's get started on making our two new pistons. And the material we're going to be using to make our new pistons, it is a 1045 grade, it is 240 mil in diameter, and it is 110 mil thick. Righto guys, so we're just doing our final measurement on the length of our piston. Because I can't get my caliper in behind the piston because the chuck is in the way, I know this machine very, very well, and I know from the face of my chuck to the bottom face of that jaw is 9 millimeters. So what you can do with your standard calipers is you can put your fixed jaw up against the face of the chuck, and then your sliding jaw, you can bring it up to the job. So we have 111.3 mil, we minus the 9 mil off that, and that will give us the size we are currently at. Then we can adjust our tool and make the final cut. Righto guys, so I finished all the turning on the ID for this piston. So what I need to do now, I need to get the second piston up to this stage. Then we can change the setup and we can do all the turning on the OD. Righto guys, so we have machined our 2 grooves for our pressure seals. What I need to do now is machine the groove for the wear band. The wear band is a super critical measurement because the wear band material is so hard, it has no give, which means it does not compress at all. If that groove is slightly oversized, and I mean a couple of thou, you pretty much won't be able to reassemble that cylinder, and if you do get it assembled, it is going to have a lot of trouble trying to cycle. Super important we get that measurement spot on. Righto guys, our 2 pistons are now complete, but because I still need to make 2 new apron barrels and 2 new rods, I've sprayed these down with a rust preventative and have wrapped them up, and we're going to put them to the side until I get those other parts completed. But that's the pistons done, so thanks for watching. Hand on straight.
Yep.
Yeah. Righto guys, so we're up to the last step on the first piston. Right, so the wear band material is a very hard Righto guys, so our 2 pistons are now complete. Where are we going with that? Wait, where am I starting? Righto guys, so our 2 pistons, fuck up man.
Yeah, you going good?
Right, yeah, fuck. Hang on, ready? That was good. And the material we're going to be using to make our new pistons, it is a 1045 grade, it is 240 mil in diameter, and it is 110 mil thick.
Very good.
Amazing.
Your hat's not straight.
Fuck. We're going to put these to the side so I can now continue on with the rest of the rebuild. Thanks for watching. What?
Bar's too big.
That's what she said. Just check that.
Yeah. Sit. Oh my god. Oh god.
So this is the result of those 2 pistons and 1 other small job. After every job, we sort of empty the machine, throw it in the bin, so now we can mess it up for a new one.